unless it's like a calculator or something expensive. So like if your ruler has your name on it and you lose it, like I'm going to put it in the back of the room. Sorry, before I move on, you should have 833. A couple you got in yesterday, but like, sorry I didn't hand everything out. If you want any of the other homeworks for the, well, it's only 834 upcoming. You can go get them at extensions or whenever. You should have blank computer paper, because graph paper will actually get in the way today, because it kind of, you'll, centimeter ruler, we're only looking at the centimeters of it. Okay, even though most rulers have inches and centimeters, we're only looking at the centimeters. Protractors should have been in the bin. We need to review how to use a protractor real quick. So everyone get your protractor, put it in front of you. If you're missing anything else from back here, come get it. None of them was 0 centimeters. As long as it has 0, or you might just have to do some subtraction. Hey, so here's what I mean about some of you might need to do some subtraction. Hey, I don't know why, but some of you need the reminder that when teachers are talking, you stop talking. I mean, if you have something to say, just raise your hand and we'll let you talk. So if I grab a centimeter ruler that doesn't have 0, I might just measure everything from 10. So if I want a line that is 5 centimeters long, I'll go from 10 to 15, right? So I might just have to do some math since previous students have had a lack of self-control and broken the materials in my room. So today we're going to practice constructing shapes, but before we can construct shapes, we need a review of how a protractor works because some of us might forget how to use this. So everyone look at your protractor, and can anyone tell me what I'm doing wrong? It was up, then it went down. Is it up? Okay, Zach?
It's not like, okay, it's not like straight. It's like this.
Well, this is why we're using blank white paper. There is no straight on my blank white paper.
Yeah, but like, if you have shape.
Well, so if, you're right, if I had a shape or a line drawn, I'd want to line up with that shape or that line, but I don't yet. Noah?
It's upside down.
Okay. You said it was up.
I mean, like,
Pick it
you
up.
need to pick it up.
Oh, you mean I need to be able to read the words on it, and the numbers should be facing the right direction.
Oh, that makes so much
Oh, that makes so much sense. And then as we have a line, like Zach said, we want to square the protractor up on the line that we would already have drawn. So everyone make sure that before you start using a protractor, you should be able to read the word at the bottom. This point where the arrow points is your 0 point. Now, reminder, there are lots of types of protractors. Some that will put your vertex in a little hole. Like this, I would line up the end of my line in that hole. Some that don't have like any hole or any gap even. Like big ones, small ones. Some that have like the little lines all the way through, which some of us like these. I mean, you could even use 2 protractors at once, right? Like, but the ones that we're going to use together, since I have a classroom set of them, mine is pink, but all of you should have gray ones that say whatever this word is at the bottom. It does say made in China because they are made in China. All right, so I want you, and actually I forget what things were on your worksheet or not. Yeah, your directions are on your worksheet. I want you to draw a triangle. Dude, how long am I going to stare at you before you realize I'm looking at you because you're spacing out? Draw a triangle with one edge that is how long? 1.5 centimeters and an angle that is 60 degrees. And you could, now guys, put this somewhere, like not the dead middle of your paper, because you know we're going to do a few different problems. So maybe top left, maybe top right, but like put it somewhere convenient. Yeah, too bad, so sad. So I might label this like 833, right? Just so I know what this paper was. So when I put it in my binder and I have it to refer back to. And if you're going to label that, we might call this constructing shapes. And today is the 10th. So for me to do 1.5 centimeters, I'm going to have to go from 10 to like 11 and a half. Right? So not very big. And guys, anytime we have directions about what to do, we're going to label that. So make sure that below your line that you made 1.5 centimeters, you indicate that you made it 1.5 centimeters. Well, let's go back and double check. And it's on your paper, right? This is on your homework paper. One angle that measures 60 degrees. Yep. Well, could be. So hold on. We'll go back to Sam in just a second because you're letting the cat out of the bag, Sam. Who put the cat in the bag is the question. Guys, let's try to like all agree with each other for a moment. For 60 degrees, if I go on the left vertex and I place my little line, like this little line on the protractor to point right at that point, and I line up square like Zach had told us. Now we have a straight, right? Like now I have a straight line to follow. This is why we said don't use graph paper. It gives too many lines. But now 60 degrees, I kind of created an issue here. 60 is off of my paper. Is there a way that I can deal with that and still use 60, but maybe not actually use that 60, Lucy?
Well, you could. This probably isn't the answer that you're looking for, but you could use your ruler and like make the line.
We could use our ruler and like make the line. But guys, notice how there's two sets of numbers here. One is counting from left to right, and the other is counting from right to left. But anyone notice anything interesting about 70 and 110, 80 and 100, 60 and 120, 50 and 130? They always add up to 180. So guys, if I can't get to my 60, I can use my 120, but know that that's actually my 60. But if I put a little mark right where that's at, now hold on, does my side need to actually go that far? No. What I need to do is line up with that angle. So, and if we put this too close to the top of the paper, we might need to scoot it down. So I can draw like a guiding line that says, okay, this will be 60 degrees. I don't have to use that entire side, and I could actually go as far as I want to, because did it tell me how big to make this side? No. So are we all going to have identical triangles? No. I am doing right triangle math with my other class, so I'm going to try to make this a right triangle by making this angle right. So I'm going to line up my ruler and just whoosh. But I could also go out to where I marked the point, and I could make my triangle look like this. I could actually try to angle it in and sort of make it look like an equilateral triangle. Yeah, see, math has sound effects. So guys, we could get a bunch of different triangles because they only gave us two pieces of info. One angle, one edge. Noah?
It says one side has to be 5 centimeters long too.
Is that in part A? I think you're going too far. This was just 80. So if you want to on your paper off to the side here, you might want to number this was 80. So now go ahead and look at the next one on your paper, right, which is 81. So look at the directions of 81. I'm going to grab one of these so I know what's on your paper finally. I think it's just these two. Ooh, a quadrilateral. What's a quadrilateral? 4 sides. Now, Zach reminded us that we can't do an angle unless we have a side. So what might we do first here? The 5 centimeter edge. That might be the better place to start because it's really hard to make an angle without any edges. So I'm going to give you a head start. Actually, I'm just going to minimize my camera. So now we have 3 pieces of info, 2 angles, 1 edge. Okay. Well, it's okay if we goof it up, scribble it out, and try again. You don't even have to erase. Oh, there's no right answer.
No, I mean I didn't fit all the requirements.
Oh, okay. Yeah, there's only 2 requirements, but that means that we'll have infinitely many triangles that we might have. Like, literally infinitely many. Remember to label everything you draw specifically. So your 5 centimeter line should have a label of 5 centimeters.
This wasn't so time consuming. I'd actually say it was kind of fun.
So, only things that are easy and don't take much time are allowed to be fun.
Sure. You said the bad word.
I know, but that's essentially what soap is making it sound like.
No,
That
I'm
because
just saying
this
it's just too
soap
much math.
takes time and effort. Oh, hey, there's one more 0. There's a couple rulers back here that have a 0 centimeter. If anyone still needs one.
So if there's no such thing as too much math.
You sound like a
Yeah,
math
so-
teacher.
My mom sounds like a math teacher. That's 'cause she is.
But wait a minute. Your drawings are different.
Oh my gosh, no, wait, for real? No.
Now, we're drawing on blank white paper to make our life easier because the lines of line paper are going to kind of confuse your brain. So that's why that was part of the directions.
Awkward.
I just got people.
I know, but I had a stack of blank white computer paper back there ready for you guys. So, I need some help. We haven't done random cards in a hot minute. I did it. I did it. Mason, where do you want me to put my 30 degree?
On the left side.
On the left side. So we will line up our bottom of the protractor with that little tick. And am I going to use this 30 off my page or this 30 over here? I'm using this 30 because, guys, always look for where is your 0. Where is my 0? It should be on my line. So my 0 tells me which set of numbers I'm using. So now we mark 30. Or kind of 150, right, in a way, but it is 30. So I'm going to sketch that, but I'm not necessarily going to use this entire thing. Guys, remember that when we're constructing shapes, we can erase. We cannot use the entire thing if we want. That's why after my line that I know the length, I'm just going to work in pencil. And then they say a 60 degree angle. Zach, where do you want to put my 60?
On the right side.
Like the right side of this?
Yeah.
So if I now, am I using this 60 up here on the right or this 60 down here on the left? This one, because I look for my 0. My 0 should be on my line. Right, and my line points this way, so I'm using the inside set of numbers. So now 60, well, wait, this is weird. If I do this, I don't get a quadrilateral.
Different length.
You can just make it.
How could I make it a quadrilateral, Zach?
Yeah.
So this was 30, this was 60, so we did what we're supposed to, but now what could I do?
Erase that access and then a bit more, and then connect those two lines with another line.
Erase, oh, so just like do,
Yeah, like that.
could I make it kind of like a trapezoid maybe?
Yeah. That's what I do.
So guys, if I erase where they intersect, because I don't know how long these other edges have to be. Now, will we all get the same thing? No, not necessarily. But everybody should have an acute angle of 30. Now, hold up, though. What if, because I saw a couple of you do this, Rin, I think you can probably guess where I'm going.
I think because I thought I did it wrong, maybe because my 30 is not an acute angle.
Then you did do it wrong. 30 has to be acute. I bet you lined up off 150 by accident.
I think I did.
So guys, if I go back, here's my 5 centimeter line. I'm going to make my 30-degree angle. So again, if you need help making the angle, we line up. Nope, I'll use the one that matches you guys. We line up the point on our point, but then whichever direction our line goes, that's where we search for 0. Boop. Outside numbers. So I'm using my outside numbers, that 30. And Annabelle, I think you did this. Do I have to do my 60 degrees off my 5 centimeter? No. So I could, off wherever on this line I want, I could do my 60 degrees off there. So again, line up. I'm using this 0. I can go to 60. Ooh, and that does like this. So this is 60 degrees. This was 30 degrees. And then can I make this a quadrilateral? Sure.
Oh, I thought you were going to
if you
connected
connected
it to the bottom, it would have been flat. Yeah.
Like this? That wouldn't be a quadrilateral.
No, down to the other.
Oh, you mean down to like here?
Yeah, it looks more like a flag.
No.
Sure.
It looks like a bird.
It looks like a stealth airplane. Right? Like one of those like... So guys, both of the... Hold up. Hold up. Because then I'll let you like draw for a little bit. Both of these did the same thing, quote unquote. They had a 5 centimeter, they had a 30 degrees, and they had a 60 degrees. So what this is saying is if you're going to tell somebody how to draw something, you're going to have to be really particular. All right, let's try another one. See if we can maybe get on the same page here. So 81, 82. But that's homework. So you now get to come up with a challenge. So I want you to, on your paper, follow a set of steps to draw a certain shape. What you want to do is try to figure out, can I say those steps to somebody else and they draw the same shape that I did? Because in both 80 and 81, we got different shapes, right? Like our triangles look different, our quadrilaterals look different. So I will tell you, triangles are maybe easier because there's less pieces. So on your paper, like you get to just freehand draw, like use a ruler to measure and use a protractor, but draw whatever you want, and then come up with the directions to try to get somebody else to draw that. Could. It's going to be complicated to explain, but...
I would like
Did I say no?
What if we had 5 billion?
Okay, doing hexagon.
You're doing a hexagon?
I mean, there's kind of hexagon.
This one. Thank you for the request.
Yeah. Yeah.
I think.
It depends on which way your line is pointing. So if you're on this vertex, your line is pointing that way, you're starting at that 0. If you line up on that vertex, you're pointed this way, and you're using this. Make sense?
Yeah, so it's 0.1 letters.
Wait, yeah.
Like the tiniest line. What if your line's like 10 degrees? You can't really make a mark on one either.
Yeah, you have to make it really far out, right? And then just kind of connect it.
Made it.
I don't have room for that.
All right, so let's. I'll get you in the mode of this. So everyone, grab your ruler and protractor. And if you're ignoring me, you're hurting my feelings.
I'm not ignoring you. I'm just not
Draw. Listen to the directions first. Draw 2 lines of 8 and 10 centimeter. Or no, wait, sorry. 6 and 8 centimeters connected by a right angle. So draw two lines. Draw two lines of 6 and 8 centimeters connected by a right angle. Then connect those lines and measure the third side. Yep, make two lines, 6 and 8 centimeters, connected by a right angle. So effectively, what I'm telling you, if I write out what I'm telling you to do, 6 centimeters perpendicular with 8 centimeters. Then connect those two lines, there will be like a diagonal that they make, and measure that.
The angle or
The length.
oh, wait, but that doesn't.
You're right, but what is the hypotenuse?
Hypotenuse. I want to hit hypotenuse for Christmas.
I got it.
So keep it to yourself for the moment. So 6.
Okay, I'm gonna get
I went longer than 6. All right, 6 is right
Wait,
here.
right angle is 90 degrees, right?
Yeah, so to make a right angle, you're really just going to make it be perpendicular. So, I mean, you can essentially visualize like
Just
the
make it go up.
edge of a piece of paper. Yeah, or your ruler kind of helps you go perpendicular with the tick marks on it. So if I want this to be 8, I'm going to make sure I have a 90 degree because otherwise this won't work. So guys, this is my 6 centimeters. I'm going to make certain we're perpendicular by lining that up and marking my 90. Then I'm going to draw my line and then measure it. Like, now I'll line it up to be perpendicular, but I'm only going to draw this line 8. So we made this 90 degrees. What is the length of the third side? This is what is known as a Pythagorean triple. It's a fancy pants, not really fancy pants, I shouldn't say it. It's the simplest types of right triangles that use all integers. So the most basic of that sort of triangle would be if we only went 3. So if I measure 3, that's like my halfway point, right?
3, 4, 5.
And then I measure 4. And the distance between them ends up being 5.
So 6, 8.
So 3, 4, 5. Or we can dilate it up to 6, 8, 10. This is what we call the 3, 4, 5 Pythagorean triple.
That was the Pythagorean theorem.
So that works for any right triangle, Val. But this is this specific right triangle. So Pythagorean theorem works for any right. Pythagorean triples are special right triangles. So like those directions I gave you, make 6 centimeters, 8 centimeters connected by a right angle. Like that made us all have the same triangle. That's what you want to try to do for a friend, for a partner. Bryson?
What if I didn't do it like that?
Then you didn't follow the directions.
Well, you said
My directions were make a 6 centimeter and 8 centimeter connected by a right angle. Then connect those together.
I knew the connected one.
I think you were talking to Lucy and Leah. It's okay.
I made the 8 centimeter the slope down.
Yep, that kind of goes to show if we're not fully listening. debating being too nice.
Please, be too nice.
Be nice.
Be mad.
Well, the homework competition is still going on. And this homework that you have is really not very big. But I was about to say, just take the rest of this time to work on your homework.
Yes, please.
Okay,
Yay.
sure.
Thank you.
Okay, so should we finish this and then do the homework?
I mean, those of you that choose to do this, you can do this whenever, of like challenging your friends to draw what you want them to draw. So guys, what like the reason I am kind of deciding like let's just go ahead and spend some time on homework is we're trying to get through geometry really quickly, and I want to make sure that this sort of stuff makes sense. So this does not mean measure. This means approximate. So guys, for 85, I want you to like put your protractor to the side and just draw an approximate picture. And I would like to come around and just kind of like check and make sure that we're doing okay. Reminder, the 832 we're going to check tomorrow. And we're going to start getting in a new like effort grade sheet. So I've got new ones for you that I'll give out. But remember, we got the homework competition still rolling. I'll talk about this at forum because I'm probably going to forget to do it in every class. You have to win by 2. So if you guys win this week, that's great. Good job. Do it again. Right? So we keep doing this. Like, we keep tying back up. You got to win by 2. Okay? So, and that goes for Math 7, too. So, like, whichever class is going to win needs to win by 2. Because if we just keep tying it back up, we'll keep pushing it on. Yeah, I need to put one more Post-it up there for you guys. But remember, moving forward, we're combined. It's all of Block 3, right? And all of Block 1. It's percent of students in that block. Not just period versus period. So go ahead and dive into this without a protractor. I want you to approximate these angles. And guys, especially like the 190 and the 270, if you're confused, stick up a hand and like, let me come help you. Or talk to a neighbor. Like talk to a friend. How do we draw angles bigger than 1? Yeah, there you go. Yep. Wait, this is for like 80 or this is for like, oh, that is your 50. Well, then for the 80, you don't use a protractor. And your protractor doesn't even have like 190 or 270, right? Like those angles aren't even on a protractor. Yes. Oh, ruler. Guys, a straight edge is just a, like, it's saying you don't need it to be a ruler. So anything is a straight edge. Like anything that's straight. Another piece of paper, right? Like a note card, whatever. If you would like a glimpse into how nerdy I actually am, inside Mr. Hudson's wallet, literally, I keep on me ruler, inches, come on, focus, inches versus centimeter, and all of the appropriate mathematical conversions. So when I'm hanging out with my friends and somebody starts arguing how many what is in a what, I can pull this out and prove them wrong.
How often do your friends
So-
start arguing about that?
Once you're an adult, you argue about weird things, and there's become this new, like,
My friends
for a
argue.
while, everyone Googled everything, just like immediately, just like Google it. But now it's like more fun to talk about it for a bit before somebody searches it up. Like how many teaspoons are in a tablespoon? How many teaspoons are in a tablespoon?
4.5.
3.
No. Can you just copy me?
No, I actually know that as a fact. I don't know.
What, Lucy?
It's great.
I think I know that as a fact, but it could be wrong.
I remember.
No, you're right. I was just trying to check if it's actually on this card.
I remember one time my friend was saying that December was the 11th month in the year.
Check
And
it.
we started getting into an argument, and I said, "Dude, let's just Google it." And he's like, "No, we shouldn't Google it." And I'm like, "Why?" And he's like, "I don't want to."
A teaspoon is 5 mils. A tablespoon is 15 mils. There are 3 teaspoons in every tablespoon. So also, why I'm showing you this, those other rulers back there that are not clear. if you are trying to convert something, if you are trying to do a math problem, and you want to avoid just Googling, these rulers that you may borrow but not take, these rulers have conversion sheets on them. So they're really convenient. It's like my little pocket one, but these rulers have conversions on them. Huh? Oh yeah, there's a set in the plain book too, but Mr. Estes makes that. Ah, this is also why I wanted us to get to this problem.
Oh, I know.
Diameter,
I know.
radius. Where might you look to find help on problems like this
My
in this?
dad. No.
The math notes or SOSTAT.
Mr. Hudson, I need to know your dad's phone number.
No, we're recording. Let's not do this, even though it's funny. So what?
He didn't get any questions wrong in math.
Was it for accounting?
No.
Oh.
No, it was like wasn't it?
ACT. There's ACT and SAT.
Yeah, it was one of those. But anyway, I was gonna say I know something.
Okay, you know something?
I know
I hope
something.
you know lots of things.
Yes, hopefully on 86 decimals out of 20. I know that. But I got it wrong.
Hey, when you guys go to leave, you can leave your rulers on your table with your protractors. You can just leave stuff out on your tables because the next class will be using them. Is there anything else that we need to go over? Back here, you should know these rules. I will say on F, if you work one angle at a time, it is definitely solvable. And on any of these, you could not just fill in the one that they're asking. You could fill in every single angle if you want to. So just to kind of get on the same page, anyone already have 190 degrees or 270 degrees done that you want to share with everyone? Colin, you want to come share one? And Liam, you want to come share one? So Colin, come on up. You can drop it under the... Yeah. The 270 is not quite big enough. Yeah, so Liam's going to share the 270. So Colin, share the 190.
Can I do 270?
So how did you, think when you were trying to draw this?
Because 180 is a straight line.
180 is a straight line.
I just added what I thought was about 10 degrees.
So guys, if you can envision, yes, old school ruler, 180 is a straight line. So Colin said go a bit bigger, right? So instead of just a straight line, I have a straight line plus 10 extra degrees. All right, thank you very much. Liam, want to show your 270? It's just an old school, before they had measuring tapes, this is how you could fold it up and make it smaller. I inherited this from a relative.
Also, you
Go
can
ahead,
use
Liam.
it to measure quarters.
So I just really did this one with 180, so 1/4 of 360 is 90. So then 80 plus 90 equals 270. 180 plus 90 equals 270.
So the whole this side. So Liam said if this is 90, this... So you got to draw the arrow around the outside, right? Like Liam did, arrow around the outside. All right, keep working. Question, Sam?
My dad wants whoever gets done last has to take the ACT. And they're supposed to score outside the classroom. And also they have to have a poster.
Are they all teachers?
Yeah.
Okay, that makes sense.
And so, some of the high schoolers can have a giggle if they scored less than their math.
Right? I mean, or you mean, well, yeah, the high schoolers would hope they maybe score better, but yeah, I scored okay on the ACT.
My dad used to skip classes, so he didn't score.
My dad's crowning achievement is his ACT.